Hi, welcome back. In this video, we're going to talk about what to do with exponents when you are dividing two different terms or more terms. If you have not watched the previous video, Properties of Exponents Multiplication, I strongly recommend that you get comfortable with multiplication before division, because later in this video, we're going to talk about some examples that involve the multiplication property of exponents. Here, we're going to focus mainly on different properties of exponents when you're dividing. Now, while you're here, if you have not subscribed so already, go ahead and click the subscribe button. And if you find something useful in this video, click the like button. It lets me know that it was useful to you as well. All right, let's begin. Now, here, before we begin with this first property, quotient of powers property, I want to talk about how would you go about solving this problem using the expanded form, right? Expanded is when we are expanding the top term, 2 to the 6th power, and 2 to the 3rd power in the bottom. We're going to expand them and we're going to divide these things, right? So what you're going to want to do is find another representation of 2 to the 6th. The expanded form would be 2 times 2, 6 times. Right? That's 2 to the 6th power. In the bottom, we have 2 to the 3rd, which means we have 2 times 2 times 2. We're multiplying 2 times itself 3 times. Now, if we're actually going about dividing here, right, what's going to end up happening is we're going to be able to cancel the terms that we have in common in the top and in the bottom. So these two cancel, these two cancel, and these two cancel. And now on the top, we're just left with 2 times 2 times 2, which is equivalent to 8. Right? If you want to go about the long route, you can also just multiply 2 times 2 times 2 times 2 6 different times. And you get 64. And you can divide it by 2 times 2 times 2, which is 8. And in the end, 64 divided by 8 is the same thing as 8. Right? In this other notation on the right, in this example, we have x to the 7th divided by x squared. So expanded notation would look like this. We have x times itself 7 times. X times x times x times x times x times x. One more x. To the 7th power divided by x squared, which means that there's only 2 x's. As I start canceling, what's going to end up happening, right? I'm canceling this term and this term, leaving me with 5 left over, 5 terms. So I have x to the 5th power. Since I don't have a value of x, I'm just going to leave it as x to the 5th power. Now, what I notice here, though, as in the previous example, I had 3 left over. Right? Here I had 3 left over in the top. Here I had 5 left over in the bottom, and the top as well. If I look at the exponents, 6 minus 3 is 3, and 7 minus 2 is 5. Since we're canceling or taking away 2 of the things that they have in common, we're going to be left with the difference. 7 minus 2, you're subtracting 2 of them, you're going to be left with 5. So this property of quotient property, this first rule, what we want to say is whenever you're dividing two things that have the same base, a and a, what do we do with the exponents? We subtract them. That's going to be our shortcut. So we have a to the x minus y. You always end up doing the numerator subtracting the denominator. And that's our property, a to the x minus y. So let's try some examples. So we know the property is a, here, let me write it up here, x minus y. The top divided by the bottom. The top minus the bottom. It's always the numerator over the bottom. So if we're looking at this first example, here we have 6 to the 10th power over 6 to the 8th power. If I subtract 10 minus 8, I can also say this is really just 6 to the 2nd power. 10 minus 8 is 2. And 6 squared is really just 36. This process is a lot faster than doing the expanded form. 6 times 6 times 6 times 6, 10 different times, divided by 6 times 6 times 6, 8 different times. That's just too much of a process. So we can use this property to subtract and simplify it much faster. In this next example, notice how we have a 4 and 2. These numbers, these coefficients are really just numbers. I can always divide those two separately and then subtract the n's from each other. So 4 divided by 2 is really just 2. And then n to the 8th power minus, right, divided by n to the 7th is really just 8 minus 7, which is just n to the 1 power. Now, n to the 1 power is really just n, right? So it's just 2 times n. Why don't you quick pause and give this other one a try? I strongly recommend that you work these out yourself and give them a try. As you start dividing this next one, right, when you start dividing the 7 and the 14, it's really 1/2. 7 fits into 14 twice. Now, when you're grouping these, the x's, we subtract the x values, right? The x exponents. So we're dividing these two. These are like terms. So 12 minus 4 is 8. So I have x to the 8th power. Technically, I still have the 1/2 in front, so we'll work on that in a little bit. And then in the back, we have y to the 9th and y to the 3rd. We subtract the exponents, and now it becomes y to the 6th. Now we still have a 1/2 in the front, so we can put 1/2 times x to the 8th or y, and y to the 6th. You can also write this as 1 times x to the 8th times y to the 6th divided by just 2. Right? Since the 2 is in the denominator, we can just make one big fraction and write it in the bottom. So the rule here is subtract the exponents when they are like terms. These are like terms because they have x as the base, and here they both have y as a base. Now, here we get into a special scenario. If we were to do the subtraction property, right, that we just learned, what would we do with these exponents? We do 3 minus 5. Now, when you do 3 minus 5, you'll actually end up getting a negative exponent. Okay? We'll talk about this property here in a minute. If we're dealing with the expanded form, let's move this out of the way. We know what the answer is going to be. Okay? If we're dealing with the expanded form, this is what we're working with. We're dealing with 8 times 8 times 8, 3 different times, divided by 8 times 8 times 8, 5 different times. As you start canceling things, right, 8 divided by 8 is 1, 8 divided by 8 is 1, 8 divided by 8 is 1. And the top, since everything got canceled, we really just have a 1 in the numerator. And in the bottom, we have 8 squared. So we have 1 over 8 squared, or 1 over 8 times 8, which is 1 over 64. Okay, so this value that we looked at earlier, -2, is really the same thing as saying 1 over 8 squared. Notice how the negative exponent got flipped over as a fraction and became a positive number. Let's try it again over here and see if that's a property that's happening. So if we subtract the exponents, we know we're supposed to get y to the -3. 5 minus 8 is -3. If I do this in expanded form, I have y times itself 5 times. And we're dividing by y times itself 8 times. 2, 3, 4, 5, 6, 7, 8. As you start canceling y's, we're going to be left with 3 in the bottom. So we're going to have 1 over y to the 3rd power. And as I said earlier, this negative exponent can be written in the same way. Right? This is really just this. Now, y to the 3rd power is just y to the 3rd. So whenever you're dealing with a negative exponent, here we were able to simplify the number because we're dealing with numbers, but we're dealing with variables, we just leave it with variables. If you have a negative exponent, you can actually do the reciprocal, right? Technically, right now we have y to the -3 divided by 1. You flip it, and you make it positive, 1 over y to the 3rd. Okay? You flip the value, and it gives you the equivalent in positive form. So if we're looking at the general rule, a to a negative exponent, you can say it's the same thing as saying 1 over a to the x power. That is the negative exponent property. So anytime that you're dealing with a negative exponent, you want to make sure that it turns into a positive exponent by putting it in the bottom. So if you're solving a problem like here, we know we're dealing with 3 minus 5, which is negative 2. We can't really have a negative exponent, so we write this as a positive exponent by putting it in the denominator. Let's give some a try. So here I have 6 to the negative 7th power. I want to turn it into a positive term. Remember, the rule is to turn it into positive, we make the a value stays the same and the x turns into positive. That's really what's happening here. You're flipping it into a fraction. So 6 to the negative 7 is really the same as saying 1 over 6 to the 7th. Now 6 to the 7th power is 6 times 6 times 6 times 6 times 6 times 6 times 6, which is the same thing as saying 279,936, which is some crazy number. I think that if we leave it as this, I would be completely satisfied. Let's look at this one. Here, the exponent is negative. How do I make this a positive scenario? We don't want to work with negative exponents, so we always do the reciprocal. Right now, since it's in the bottom, we're going to flip it and put it on top. This will then turn into x to the 10th power. The 1 over x to the negative 10 flips over and becomes now the x, instead of being in the bottom, it's on the top. Now, you could technically put over 1 if you're flipping it, but anything divided by 1 is itself. So I'm just going to write it as x to the 10th. Let's try this next scenario. Now we're actually dividing. Remember, the quotient rule says you subtract the exponents. So what's negative 5 minus 7? All right, what we're dealing with here is x to the negative 5 minus 7. We're subtracting the exponents, which turns into x to the negative 12. Negative 5 take away 7 is negative 12. We don't want a negative exponent again, right? So what do? We flip this and we put that 12 into the bottom of the fraction to keep it positive. So we say this is the same as saying 1 over x to the 12. This next example is a review from the last video, multiplication property. What do you do when you're multiplying? When we're dividing, we subtract. When we're multiplying, we're going to add the exponents. So what's negative 5 plus 9? That's really what's happening here. We have y to the negative 5 plus 9. Negative 5 plus 9 is 4. We have y to the 4th power. Is the exponent positive or negative? Positive. So we leave it as is. If it were negative, we were supposed to flip this over to keep it positive. We're always looking, no matter the situation, for positive exponents as our final solution. All right, now let's talk about this other special case. What happens when you subtract the exponents and you get 0? Like 4 minus 4 is 0. What happens there? What's 3 to the 0 power? What does that mean? Well, what's going to end up happening here is if we do the expanded form, 3 to the 4th is just saying 3 times 3 times 3 times 3, right? You're multiplying it by itself 4 times. You're doing the exact same thing on the bottom. Oh, sorry about that. Now notice how every single term is going to cancel. Whatever you get on the top, if we were to do it normally, you would get 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. You're doing 81 divided by 81, which is the same thing as just saying 1, right? Dividing the top, and when everything gets canceled, right, this divided by this is 1. This divided by this is 1, divided by 1, divided, you get 1 every time. That's how we get the 1 term. So we can say that 3 to the 0 power is really just 1. And it doesn't matter what base value you have. This could be x to the 4th power. It could be 10 to the 4th power. Whenever the terms are the same, and you get 0 as an exponent, 4 minus 4 is 0. 10 minus 10 is 0. Whatever the scenario is, if you have 0 as an exponent, you're already just saying is 1. So anything to the 0 power will always be 1. That's what makes this property so special. So since we know that it equals 1, let's keep that in mind. And let's multiply things. Here we have a scenario where we're multiplying. Now, technically in the front, we have a 1 times b to the negative 7 and 2b to the 7th. The 1 and the 2 are like terms. So we really just have 1 times 2 in the front. And in the back, we have b to the negative 7 times b to the 7th. 1 times 2 is really just 2. What do we do with these exponents when we're multiplying? B to the negative 7 times b to the 7th. Multiplication is addition. Again, there's a whole video on this topic, the multiplication property of exponents. Since we're multiplying, we're going to add negative 7 plus 7. And that's just going to be b to the 0 power. Now, we said anything to the 0 power is 1. So I can replace all of this b to the 0 with just 1. So we have 2 times 1, which is just 2. In this scenario, the variable disappears completely because it's coming down to a 0 exponent. Over here, we're dividing on this next example. Division is subtracting the exponents. Multiplying is adding. Division means subtracting. So what do we do when we have 8 minus negative 8? What does that mean? X to the numerator subtracting the denominator. Minus and negative is really just another way of saying plus. So what's 8 plus 8? 16. And here, it doesn't equal 0. It actually just equals x to the 16th power. All right, here together, I put together 3 different scenarios that combines all of the rules we've discussed. A little bit of division, a little bit of power rule, different rules that we were discussing. Let's go ahead and try them out. Ideally, you would press pause right now, take out a piece of paper, and try all these out yourself. Fast forward a little bit and see if we get the same answers. That's the ideal case. Let's get started. So here we have 10 divided by 2. So that's going to give me 5. The x's, I have negative 3 minus negative 6. All right, so I have x, the numerator, subtracting the denominator. Minus and negative is just plus, right? So negative 3 plus 6 is 3. So I have 5x to the 3rd power. And that's what we get. We subtract the exponents, and I have a positive exponent, so I leave it as is. In this next scenario, 9 and 18. 9 goes into 18 twice. So we have a 2. Then we have the x values. Negative 2 minus 3. Right? Numerator minus denominator. And then we look at the y's. Numerator minus denominator. Since we only have one y, I can put 1 as an exponent. And then in the bottom, there's only one z value, z to the 0. Okay? As I start simplifying, I'm just combining like terms right here, right? The x value, the x exponent, the 2 stays the same. This x exponent, negative 2 minus 3, turns into x to the negative 5. The next term, 3 minus 1, is positive 2. And then in the bottom, z to the 0 power. Remember, anything to the 0 power is just 1. Now, because we're dealing with a negative exponent here, we want to always make sure we have a positive exponent. So what do we do with this value to make it positive? we do the reciprocal. We flip it. So instead of it being on top, we're going to put it in the bottom. So on top, we still have a 2 times y squared. In the bottom, we have a 1 times x to the 5th. Let me see if I can simplify this a little bit or move it around. So what did I do? This negative exponent, x to the negative 5th, I put it in the bottom to make it positive. And that's our solution. 2 times y squared over 1 times x to the 5th. Now technically I could also, I don't have to write the 1, I can just say 2y to the 2nd power over x to the 5th power. Multiplying times 1 doesn't really change anything, so I don't have to put it here. Let's try this last scenario. Last example for today. What is this rule called? An exponent raised to another exponent. What do we do there? Before we start subtracting exponents with the quotient rule, we have to account for parentheses part. We have to simplify this part first, right? That's what we do with PEMDAS. So, in our previous video, we spoke about when you have an exponent raised to another exponent, this is the power to the power rule. What you're going to be doing is you're going to multiply the exponents. So you really have is x to the negative 15. 5 times negative 3 is negative 15. And then you're dividing it by the bottom, which is x to the negative 16. Now that you have the parentheses go away and a much simpler form, now you can subtract the exponents using the quotient rule. So negative 15 minus negative 16. That's really our scenario. So x to the negative 15 minus negative 16. Subtracting a negative means addition. And we're left with x to the 1 power, or just x. Negative 15 plus 16 is positive 1, which means we just have 1x. All right, guys, I hope this has helped. Please let me know below if you have any questions in the comment section. Again, if you have not subscribed so already, go ahead and do so right now. Click the like button if this video was helpful to you. And as always, we'll calculate later.